Okay, just looking at arc length in radians. So if we have like a sector, and that's theta and that's r, then if theta was in degrees, then the arc length here, let's say AB, would equal theta over 360 degrees times 2 pi r, the circumference of the circle. Now, if you wanted in radians, and that angle there was in radians, then it would then be theta on 2 pi. So the 360, instead of the 360, you put 2 pi, which gives you times 2 pi r. So when you cancel out the 2 pi and the 2 pi, you end up with theta r or r theta. So the formula, which is on the formula sheet, for the arc length, which is just that part in radians, is r theta. If you want the whole perimeter of this sector, it would be r plus the arc length. So 2r plus r theta. Okay, so looking at this, if I want the perimeter, and I'm going to do this in radians, just so we get used to working in radians, it would be 3 plus 3 plus the arc length r theta, and that one is in radians. So it would be 6 plus r, which is 3 centimetres, times theta pi on 180, because I need to change it to radians. So 6 plus 3, now when you cancel out, this would be 2 pi on 9. 3 goes into 9 3 times, so 6 plus 2 pi on 3. And just as a common denominator, the perimeter would be 3 times 6, which is 18. Times 3, 18, plus 2 pi, and it'll be over 3 centimetres. Okay, so looking at this, I want the perimeter of the segment. I call it AB. So if I want the perimeter of that segment, I need, first of all, the arc length, which is theta r. So it's going to be 30 pi on 180, or pi on 6 times r, which is 6. So pi on 6 times 6, which gives you pi. So that's just the arc length. Now I need this part here. I'm going to call that x. So we've got 2 sides and 1 angle. So I'm going to use the cosine rule. C squared is a squared plus b squared minus 2ab cos c. So x squared equals 6 squared plus 6 squared minus 2 times 6 times 6 times cos 30 degrees. That x squared is 36 plus 36 minus 2 36's, which is 72, and cos 30, which is root 3 on 2. So it's 72 minus 36 root 3. So x is the square root of 72 minus 36 root 3. You could pull out the root 36, so that would be, so that's 36 times 2 minus root 3. So that would be 6 root 2 minus root 3. Okay, so looking at this, I now want the perimeter of that shaded area thing, so that there would be theta r, so it's pi on 5 times the radius of the big one, which is 8. And then we have to add on this one here, which is theta times the radius, which is 6. So that just gives me these two, and I've got to put on the 2 sides, which is plus 2 plus 2. So the whole perimeter would be 8 pi on 5 plus 6 pi on 5 plus 4, which is 14 pi on 5 plus 4 on 1. So if I times that by 5, we end up with 14 pi on 5 plus 20. And the whole thing can be over 5 centimetres. Alright, now this is working backwards. So the whole perimeter is 24 plus pi on 3. So 24 plus pi on 3, that would be on 3, that would be 8 plus pi on 3. Okay, so if I take, I know that the perimeter is 4 plus 4 plus r theta, so plus 4 theta, that's got to equal 8 plus pi on 3. So if I take away the 4 and the 4, that will give me the 8. 4 theta is pi on 3, so theta is pi on 3 times 4, which is pi on 12. And that is in radians.